This next topic is assessing PV inverter performance and reliability. And we have a great cast here to help us dig a little bit deeper into inverter performance and reliability. And just to start off, I think in the industry, obviously, we're concerned about quality. We're concerned about the reliability of PV systems going forward. But I would say 80% of the conversation that I have around reliability typically focuses around the module. And yet, if you look at studies that have been released in the past by Sun Edison or Medio Control, around 30 to 40% of the energy losses that do happen because of an event manifest themselves at the inverter. So it is an issue. It is an important issue. And I'm glad that we have these gentlemen on board to help dissect that. So just to give a brief introduction to all of them, we have directly to my left, Phil Vyhanek, who is the president of Solectria Renewables, Mark Abrams, who is the director of product management at Enphase Energy. To his left, we have Todd Miklos, who is wearing a couple hats today, one as an affiliate partner with Invect, but also in business development with PV Evolution Labs. Jim Morgenson, who is the director of strategic accounts for SMA America. And finally, at the end, we have Thomas Enzendorfer, who is the director of solar energy for Fronius USA. So let's get right down into it and let me ask, in terms of reliability, what does reliability actually mean when you're talking about PV inverters? And one of the ways that we can be a little bit more specific is, what sort of metrics do you look at when you're assessing your inverter's reliability? So let's start with Phil.
I think the most obvious thing we think about is availability. If the sun's out, is the inverter running and producing power? So that uptime or availability is probably the first thing that we think about.
Mm-hmm. Mark?
So we always like to think about it as a system. So of course the inverter's reliability is at the heart of that. It's the intelligence it needs to be on to produce. But really reliability is more than just the metric of hours per day. It's do you trust that system? Can you figure out what's going on with that system? Can you repair that system remotely? Is that system a reliable performer for you? And you would measure that in perhaps ways that you actually, how much do you have to spend to repair or maintain that system, as an example?
So you're looking more at a dollar amount that you have to budget for?
No, I think it's just a matter of measuring how you take care of the system. Can you, in fact, see it remotely and be sure that things are okay? So yeah, you would measure it in dollars, hours spent repairing. Yeah, those would be fair metrics.
Okay. Todd?
Yeah. Availability for a given purpose, considering the constraints on the system. And so, for example, running an inverter, yeah, you want to strive for 100% uptime, but if there are grid irregularities, if there are issues in the array, if there are arcs, you actually don't want the inverter running, right? Mm-hmm. So you need to also allow for, there may be times when the system is saying, please don't run, and the inverters need to do what they can to produce within those constraints.
Okay, MJ, I think if you had to pick one single metric, the performance ratio of the plant would be a good one to look at. And this will probably come up, in the next session as well, in the O&M session. But, you've got the inverters, the modules, the system performance from orientation and that sort of thing. And, if you really look at, I had to monitor one piece, I would say the performance ratio.
Okay. And can you just define performance ratio for us?
Yeah, performance ratio is, when an engineer sits down and designs what the expected output is of the plant on any given day, and it's, weather compensated, and it's also seasonally compensated. Here's your expected performance, and then you measure actual performance, and that ratio becomes your performance ratio.
Okay.
Yeah, we agree on all of those points. These are the things that we look at as well. But we take a very specific approach into what we consider reliability. And we always like to capture the room by saying we're the first to admit that Fronius has a 100% failure rate. And I would say this is true for everyone else in the power electronics field, that eventually over a time of a lifetime of a system, you eventually will face a failure of the power electronics. And the way we measure reliability really has to do with what is the cost that is involved in actually allowing that system to get back up, to be able to operate, and to be functional for the lifetime of that system. So our metrics is a little bit different.
All right, well, first of all, I want to ask the other gentleman here, would you agree with Thomas's statement, 100% failure rates in inverters over the lifetime?
How did I get on this panel again?
That feels a little like we're all going to die. I think it's a fair way to think about this in terms of it is electronics. Paul mentioned this earlier. Eventually, obviously, electronics have challenges. I think it's better to think about what do you get from that asset. And again, it's even, again, I'm going to go back to system because we look at inverters and we're focused on that here, but you just mentioned 60, 70% of the problems are modules. So how do you see that? Do your inverters tell you what's going on with your modules? Are they providing more reliability to the performance of the system? Can they see those problems as modules degrade before they fail? Can they adjust for those things? So
I want to be clear that what I meant was the conversations around reliability is 67% focused on modules and not necessarily related to modules actually having a problem in the field. But point taken with your statement. Todd, Jim, anything to add?
Go ahead.
Oh, yeah. I'm just going to add, yeah, you always got to be cognizant of lifetime, but then once you get into reliability for how well something performs to a stated purpose, assuming that there will be some failures and you model that in, mean time to repair, system response, those